Hi friends, welcome to VTeach. Now we are going to discuss about Mono Stable Multi Vibrator using the IC555 time. So we all already know about this internal structure of the IC555 timer, right? So for that we are going to add some diagram will be changed somewhat. So if you see this seventh pin will be connected over here, and this will be connected to the resistor, and this resistor will be connected to the VCC. Okay, and like this we am going to change, and this pin will be connected to 7th and 6th pin will be connected, and for the 6th pin and 7th pin I am going to connect one capacitor which we are going to charge and discharge over here. So this monostable multivibrator, we can say that one as a we are having two stable states. We can get two stable states here. One is quasi stable state, and the second stage is normal charging state. Like that we can get two different states over here. Basically, we all know that the charge pin means in the SR flip flop the Q will be high. Means here the data will be high. Means what will happen? Here the data will be high. Then automatically this will be connected to the collector, and then the discharge will occur. In the capacitor, the discharging will occur up to zero level. When the trigger pulse is connected, when the triggering is given to the comparator 2, then automatically this comparator 2 will compare this triggering pulse with the already inbuilt positive pulse, V reference pulse, that is 1/3 VCC. So this will be connected, and the trigger will be compared with this 1/3 VCC. If the value of the comparator is okay, then automatically this Q bar will be activated and the output is getting to this. Means automatically what will happen over here? So here the discharging path is stopped, and the discharging path is stopped, and then by using this resistor, the charging will be done to the capacitor up to its saturation path. So this is the main point of the monostable multivibrator. We will look at the circuit graphs, and then we can easily understand. If you see this diagram, so basically what I am going to do, so I am going to give the basically I am having at the output pin we are not having in the zero path, and in the threshold capacitor voltage I am having 0, whereas I am giving the pulse negative triggering pulse, then automatically the threshold capacitor is start charging, and the output will be giving as a high. Whereas I am leaving that, the charge will be occurred up to 2/3 VCC. After the completion of the 2/3 VCC, then automatically the discharge path is started. Immediately the discharge will start to the up to the 0. Okay. And coming to the output path, it is automatically 0. Means what will happen when the triggering pulse is generated, negative triggering pulse is generated, then the capacitor is starts charging up to the 2/3 VCC, means comparator 1 reference voltage. When the reference voltage of the comparator 1 is activated, then automatically the instant discharging is started. So at that particular time, in the output pin, the output will be 0. So it will be decreased to 0. So up to the charging time, the output is 1, and up to the normal time, the output is also 0. So like this, the monostable multivibrator will be activated. So in this one stable state is there, one stable state and one quasi stable state we can say. So this path what we are having, so this path what we are having, this one we can say as a quasi stable state, means it was charging up to the particular limit of the comparator, and later on it will discharges fastly. So the charging time is different, and compared to the discharging time is different. If we are going to the charging time, then the charging time must be T. With respect to the R and C, the charging time will be there. So we all know that formula that T equal to RC. So with this particular formula, the charging time will be there. Okay. Next we are going to discuss about the derivation for the pulse width. Okay, and coming to the capacitor increases, the capacitor is increases, the charging of the capacitor is increases, then Vc equal to V into 1 V multiplied with 1 minus e power minus t by Rc. Let's take an point that Vc equal to 2/3 VCC and V equal to VCC. So 2/3 VCC equal to 2/3 VCC equal to VCC multiplied with 1 minus e power minus t by Rc. Okay, this VCC will cancel. So 2/3 minus 1 equal to minus e power minus t by R. So this minus will be cancelled, and here minus 1/3 will be here. minus e power minus t by RC. This minus will be cancelled. Means 1 by 3 equal to e power minus t by RC we can get. So we are going to apply the log on both sides. Ln of 1 by 3 equal to ln of e power minus t by RC, that equal to minus t by RC. So if you are applying this log to the 1 by 3, then we can get minus 1.0986. So we can say that t is equal to approximately equal to 1.1, approximately equal to 1.1 multiplied with Rn. So this C will be measured with farads and the resistor will be measured with ohms, and T for we can say that one as a seconds. Okay, and the pulse width will be denoted by the W as given by W equal to 1.1 into R into C. So now we can see the schematic diagram of the monostable multi vibrator. So as we discussed that, so the 7th and 6th pin will be connected shorted, and this will be connected to the capacitor, and here one resistor will be connected to the series, and this resistor will be connected to the VCC path, and 4th and 8th pins will be connected over here. So if I am giving the triggering input, so this triggering input will changes all the data. So when we are giving the triggering pulse, negative triggering pulse, then automatically the charging will start it up to 2 by 3 VCC, means comparator 1 data will be monostable multi vibrator. To have the noise filtering, we are going to add this 0.01 microfarads capacitor to the pin number 5 of our IC555 diamond, which we are going to use as a monostable multi vibrator path. Okay, and coming to the applications of the monostable multi vibrator, so we are having the important 4 applications. They are one is a frequency divider, and the second one is a pulse width modulation and linear ramp generator, and the last one is a pulse suggestion modulation. So by using our monostable multi vibrator using a IC555, we can work these different types of applications in our monostable multi vibrator. Okay, thank you.